Hello everyone, I'm Sonali Suprabha Maharana. I'm currently pursuing my post-graduation at B. Surendra Sai University of Technology. With this, I would like to thank Emerge Information Technology for providing me this opportunity to be a part of this IoT internship. During this internship, me and my team, Chandan, Priyavata, Priyanka, have built a project on IoT-based home automation solution. I would also like to thank our project guide, Jayalakshmi ma'am, who taught us various concepts that are required for this internship. Next, I will move towards our first slide that contains all the contents that were covered during internship. In this 1 month of internship, we learned various concepts like C programming, C++ programming, Internet of Things, embedded system, and microcontrollers. Next, we will discuss project in the following way. First, we will discuss objective, then requirements, then design, then components and implementation, lastly simulation and demo of project. Next, in the first week, we learned about C programming. C is a general purpose language developed by Dennis Ritchie in 1972. The C language is procedure and structure oriented language. It is also called as the mother of all programming languages, as other programming languages like C++ and Java borrow the syntax from it. It is widely used to develop OS like Linux and Windows and embedded systems. Next, this is the basic structure of C programming. Here, has include stdio.h. This is the command include standard input output header file from the C library. Int main, it is the main function from where C program execution begins. Open braces indicates the beginning of the main function. These two symbols represent multiple comments. Print hello world, this command prints the output on the screen. Then getch, this command is used for any character input from keyboard. Return 0, this command is used to terminate a C program and it returns 0. Close brace, it is used to indicate the end of the main function. Next, the topics which we learned in C are data types operator, flow control statements, function, recursion, array and pointers, strings, structures and union, preprocessor directive and macros. Then our next topic, C++ programming. C++ is the extension of C language. This supports all features of C along with the classes and objects. It provides template and standard template libraries such as list, tag, queue for the simplicity of the programmer. The quantity of predefined functions and libraries of C++ make it overcome C for large implementation area. C++ is mostly used in competitive programming and game development where time is a big factor. Thank you. The next to this will be continued by Chandan Pradhan.
Hello everyone, my name is Chandan Pradhan. Today I will be discussing about IoT, that is Internet of Things. IoT describes the network of physical objects that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. Now, let us see application of IoT. Application of IoT are not restricted to a certain domain. They include various fields such as smart cities, energy engagement, wearables, agriculture, cars, smart manufacturing, transportation, healthcare, and smart homes. As you can see, I have listed some examples on application of IoT through this diagram. Moving forward, now let us see embedded systems. Embedded systems is an integrated systems such that it forms as a combination of computer hardware and softwares for specific functions. These are based on microcontrollers and uses communication ports to transfer the data in between. Generally, these comprise of processor, power supplies, memory, and communication ports. Some examples of embedded systems are engineering calculator, anti-lock packing system, airway control system, industrial robots, and digital camera. Now, these are the hardware components and software components that forms a embedded systems. Now, let's see microcontrollers. Microcontrollers is compressed in microcomputers manufactured to control the peripherals of embedded systems over an embedded system network. A typical microcontrollers consists of processor, the memory such as RAM, ROM, serial ports, peripherals like timers, counters on a single chip. Based on the bits, these are of three types. One is 8-bit, second one 16-bit, third one 32-bit. Some examples of on microcontrollers are Intel 8031 8-bit, Intel 8096 16-bit, etc. Thank you.
Hello everyone, my name is P. Priyanka Yadav, pursuing third year CSC, doing specialization in IoT at Hyderabad Institution of Technology and Management. I am now explaining about what are the programming we have to do in this project and the requirements in the project. So, coming to project overview. First, an objective is to control the garden lights, control the temperature system, control the water level of the tank. These are the main objectives we do in this project, and the requirements are Arduino board. An Arduino board consists of digital analog digital pins. It has many. We can see in the we can see the Arduino board diagram where we can find many parts in the Arduino. Next. What the basic requirements are like we have to control the garden lights on the basis of sunlight intensity, like whenever the sunlight comes in certain place we have to control the light intensity by LDR sensor, and we can measure that light intensity by LDR. Temperature sensor, temperature system control, and water tank control, where temperature system control, in temperature system control whenever the heater get cool or heater, we have to do on and off functions remotely. Like if the switch heater is off automatically, the temperature exceeds more than 35 degrees. So water tank control on off we have to do in this project, where we have to switch the inlet valve off automatically if the volume of the tank drops out like 2000 liters more below. Next, Pixim Lab is a real for the we don't use any hardware in this, so we use Pixim Lab. Pixim Lab is a real-time evaluator of a development of boards, like whatever the hardware requirements are, it is incorporated in a stimulator, where we can take that all the real-time boards and in the app only in the lab. So Blink app is it is an IoT app where we can use for controlling and sensing the data. um, Next, it is a project, it is a design Arduino. Before knowing the design, we have to very familiar with whatever the input and output. For example, LED is blinking, means it is giving an output like switching on off. So LED is an output device. LDR, it's taking the resistance, like it is um, sensing the temperature, so it is an input device. Whenever we write the programming, whenever we write these things in the programming, we have to define the input and output device very clearly, so that we cannot get any glitches in the code. So LCD actually also giving an output, so it is an output device. And Ethernet is connecting our module to a blink. And serial tank also. Next So whatever the components we used in this project is for temperature system, we used LDR, light dependence resistor, which having the pulse width modulation, and a serial remote tank in remote tank for the water control, and LCD to show the level of the to display the level of the temperature and volume of the water, and Ethernet. These are the requirements we use in this project. Blink. In Blink, we have to do we have to define the virtual pins. Like V0 is for cooler button, V1 is for temperature, V2 is for heater button, V volume button, V3, V4 is inlet valve, V5 outlet valve, V6 uh, notification. And it is the here is the code for we used in this automation. So it is a stimulation image where we can find everything in the incorporated in a uh, single display. So here is a demo of the project, and thank you.
Hello everyone, I am Priyavrata Naik. Now I am going to give the demonstration of the project that we are used to learn in the IoT internship. Here we could see that we have the Arduino Uno board that uses the microcontroller at Mega 328P. This is used to control the all the peripheral or all the embedded system that is in the network, it is in the IoT network. So let us discuss about all the modules that we have used. First of all, we know that our objective is to control the garden light depending upon the availability of sunlight. So this is the garden light. This LED strip we have used as the garden light, which all are connected to the pin to the digital pin 3. So here is the LDR sensor which we have used to control the sunlight availability of to check the availability of the sunlight. On decreasing the value, the resistance decreases, so that if the resistance decreases, then we could see that our brightness of our garden light is also decreased. If there is a more resistance, that means there is a low availability of the sunlight. So you could see here that the our garden lights have started growing brighter than the previous. So now our second objective is to control the temperature. To control the temperature through the mobile Blink mobile application. For that, I have the mobile Blink mobile application turned on my device, and I would like to represent my mobile screen on this. So now to check the actual work of the Blink mobile application over our IoT network, I have shared my screen, my mobile Blink mobile application screen to the PC. Here we could see that I have 4 buttons. One is to control the cooler, another is to control the heater, and two of these are to control the serial remote tank. One is to control the inlet valve, that is the water flow can come into our remote tank, and another is to control the outlet valve so that the water could go out of the tank. Also, we have one notification panel here which is used to display the notification, and we have two gauge. One is the current temperature gauge that displays the temperature from this temperature control system, and another is the water volume tank which displays the volume of our serial remote tank. So I would first like to demonstrate the temperature system, like how it works. So we could see that if I press the cooler on button, here our cooler is turned on, and also the cooler on notification comes on the dashboard. So if I turns it off, then it turns off, and the cooler off is shown. If I try to turn on the heater, it turns on, and the temperature value, we could see that here the temperature value is getting changed. After the value reached to 35 degrees Celsius, we could see that we got the notification that the temperature is above 35 degrees Celsius. So we have turned off the heater, and we could see that the temperature is gradually turning off, and the heater button is also off. We also got the notification of heater off on our dashboard also. So now I would like to demonstrate the use of serial remote tank. What happens on the serial remote tank? It is our serial remote tank. Here we could see that this is our inlet valve and this is our outlet valve. If I turns the outlet valve to on, we could see that the water is going out of the tank, and the volume of the water is now decreasing. When it reaches to the value 2000 liters, we have the code that the inlet valve will also be turned on. So we could see that the inlet valve is turned on, and we also got the notification here over the notification panel. We also got the notification on the dashboard also, dashboard. So the inlet is turned on. So now I would turn off the outlet valve. So we could see that only the inlet valve is turned on and the water is getting full. So once the water volume reaches 3000 liters, that means the tank is full. That our inlet valve is turned off, and we could see that our volume of the water is the tank is full. We also got the notification about saying all this. So this is the demonstration of the project. I would again like to thank Amos and our faculty, our trainer, Miss Jayalakshmi ma'am, for providing us such an opportunity. And at last, I would like to thank from all my team members, and this is a thank you.